Let me put this over here. So, 1, 2, buckle my shoe. So is it normal? So let's check. NP. What's N? 248. And what's P? 0.4. I love it. I don't know, help me out. What's 248 times 0.4? 99.2. 99.2? Okay. And what's NQ?
248 times 0.6.
0.6, I love it.
148.
And that's greater than equal to 5, right? What does that mean? It means it's normal, which means we can use z-scores. If it wasn't normal, what could we use? No, nothing. Right? And again, there's a hint to that. There's 2 confidence intervals for means. One with z, one with z. There's only 1 confidence interval for percentages, because you either use z or nothing. Third step, rejection region. What have I not told you yet? Or what do you have to assume here? What didn't I tell you?
Alpha.
Alpha. How many tail tests? Well, first off, what do we assume alpha to be? 0.05. How many tail tests? 1 tail. I know we're using z-scores, right? But I'm going to look at the t-score chart. 1 tail test, 0.05, go all the way to the bottom. What do you get?
1.645.
Kick ass. It's less than, so it's on this side, and it's negative. Right? T-score chart doesn't have negatives on it because it doesn't need to. We're the humans. We know when to put a negative one or not. If it's below the mean, it's negative. So how do I say in words what must happen? If Z star is less than negative 1.645, what can we do?
Support hard reject.
Yeah, reject the null, support the ha. Okay. So, I mean, these 2 steps are sort of not integral to the problem, but these 2 steps are necessary. I got to know what the hell I'm trying to talk about. I have to know if I'm able to use a normal. This is the major step, is where does evidence start? Right? And the example I gave, I don't know if I can never, all right, so again, even if you don't ever watch any football, whatever, if you have, the example I gave was if you have a team and they're all slow as shit and you want to get somebody who's fast, aren't you going to set a benchmark for like a certain time they have to run a certain distance? You with me? And anybody who surpasses that benchmark, that is evidence that they should be on the team. This sets the benchmark, and the next step is I let them run. I see how far did the sample get. Okay, I like it. Now that I know how far I've got to get, I go see how far the sample made it. So what do I know from this sample? What's p hat? Yeah, 97 divided by 248. Somebody help me out. What is that? I'm sorry. I'll leave.
0.3911.
391. Okay. And you can go more places if you want to, yeah. So then how do I get the Z star? So P hat minus P, what's P? 0.4. Divided by the square root of P times Q divided by, which is
248.
248. And whatever the hell that's. 209. Give me a minute, let me try. All right. Oh, I don't. Do you want to do this? Sort of. Okay.
I got negative like 289.
Okay. Negative 0.289?
Yeah.
Did we make it far enough? How far were we supposed to make it?
Beyond negative 1.645.
Where's negative 0.289? Where is it?
Between 0 and negative 1.
Like here, right? Even closer. We made it just over a quarter of a step below the mean. I really, again, if the middle really is 0.4, then any sample I take should show up close to 0.4. What does close mean? In this case, above negative 1.645. So is that us getting here, is that evidence that isn't the mean, or isn't the real middle, the percentage? No, because it's exactly where it should show up. Does that mean does that mean that the P is really 0.4? Does what we did actually mean that the P is 0.4, that the percentage is 40%? No. We just can't say it isn't. That's it. Could we have just happened to take a sample that was closer to this than it really is? Yeah. If we did another sample, couldn't we get back here? Yeah. So that's why we word it the way we do. We never accept the null. We either reject it or we fail to reject it, and we'll try again later, right? Sorry, I was thinking what I'm going to do tonight, brain. Okay. So, is everybody with me so far? We had to make it at least this far away. We did not. So right there I can say fail to reject the null, fail to support the hop. All right, little marker if you're tired.
What would the conclusion sound like? You don't have to write it, but just like.
No, I'm gonna write it, but before I get there, this is approximately negative 0.29, right? Can somebody tell me what the p-value is? What's the p-value?
It's 1 minus that?
No. That's a z-score, yes?
Oh.
So the p-value is the area in the tail that z-score makes.
1 minus the area.
No, it's just the area, right? If you look at negative 0.29, it tells you that, right? The chart tells you the area below. That's what I want. Understand? So we'd only do 1 minus if the tail was on that side.
Oh.
But the tail is on that side. That's exactly what the chart tells me.
Okay.
This is going to be a big p-value. Negative 0.2. I'm sorry. Somebody's like, why you put it all on me, man?
It's 0.3897.
Yeah, sounds about right. 0.3897.
Yeah.
We not do that. That's huge. That's a pathetic p-value in terms of what the test is trying to do, is trying to reject the null. So that's why, again, that kind of verifies. Yeah, we failed. So the conclusion, which one was the claim? The hop. So you worry about the claim. The very first thing you worry about is what the claim is, and the very last thing you worry about is what the claim is. It kind of makes sense. If somebody comes to me and they say, can you test this claim? When I come back to them, I want to say, your claim did this. This is what we figured out about your claim. So the claim was the ha. Which language do I want to use? The one that talks about the freaking ha, because that was the claim. So fail becomes, we have not found sufficient evidence. That's what fail translates into. 2, support the claim that less than 40% of Americans watch figure skating. Less than blah, blah, blah. Copy it down, right? That's what I mean by plagiarize. You're not really plagiarizing, you're just telling somebody what happened with their claim. Is that better? No? What's up?
What if the claim and the O were the same? Like if
Oh.
it was P equals 0.4 and
Yeah.
P equals.
Then we have not found sufficient evidence to reject the claim that.
So you're still trying to reject the O support the O? Or no?
when I say reject the hoe, I also just said that I support the ha. They're both the same thing. If I say this guy looks wrong, that automatically means this guy looks right. Because these guys are opposites, right?
Yeah.
Okay.
So it's always going to be that even if the claim and the hoe are the same.
Totally. Yeah. You're trying to reject the no or support the ha, right? We failed. So we failed to do both of those. So you write this down. Then you go, okay, what was the claim? Whichever one's the claim is what tells you how to write the conclusion, right? Okay. Yeah.
What told you not to subtract 1 from the
Because that is the tail, yes? So if we had a positive z star, the tail would be up here. I have to do 1 minus the area that I look up here. That's all. That's it.
Very cool. And if the problem is tails is the one it's on the right. I had that same question. I had to answer it.
And please, I don't care if I've said something 87 times. If it still doesn't make sense, ask me, right? Yeah.
1C. Probability of the 95th percentile versus asking for 95th percentile.
Which, on the praxis final?
Yeah, sorry.
So 1C, oh,
So wouldn't it just be 5%? So 0.05 would be, because it's asking for the 95th percent. Oh, it's at 90th percentile of that distribution.
so I want to know what price spent, what cost of
Right,
coffee
okay.
puts me in the 95th percentile, yeah. So that's where you have to look up a z-score, change it back into a raw score with the mu plus z sigma formula, right?
Alright, yeah, I got it. I just want to make sure I'm doing this right. If you could just give, could you give one, the writing's kind of small, so I apologize, but could you give 1B, just a quick one over, see how it looks? If you can read that.
Well, I've got the answers here. That'll make it quicker. That's fair. It's more expensive. It's burning. That's concerning. Where's your answer?
It's at the bottom P, 9.60%.
Yeah, 9.63%. The
Yeah,
one thing I
awesome.
have concerns about is right here.
Uh-huh.
That's not a z-score. That's the z-scores. This is areas. These are areas.
Right,
So
I
it's equals.
had the z equals there, I just wanted to make sure I have the areas.
Like you could, yeah. So you could put like
Z1
Z1
A.
arrow leads to.
Okay.
You
So
know
it's
that
like,
makes
just
sense.
to not confuse.
But
Okay.
if you put equals, I'm like, no.
I was like, uh-oh, okay.
Yeah, yeah, yeah.
Thank you.
Sure.
So this would be wrong because you would get if the z score star is greater than 2.576.
Greater than looks
So
good.
it would have to be the other way. Or
No, greater than. That's greater than.
So how do you know whether it's like this or like that? Like how yours is like this.
On that
is
side,
already-
because mine was less than. So to show evidence has to be down. Yours is greater than. So to show evidence has got to be up.
Okay.
So that would mean it's positive. It's above the middle. If it's less than, it would be below the middle. Negative.
Find the
6.8.
z-score. You got the z-score, okay. Now define anything in there, so you know the mean is
Yeah.
1.65,
For
right?
these, I got
And
this
whatever
one, I was
the
supposed
cost
to
is,
make it.
add
Yeah.
1.65
So I was,
and
okay.
Because you get this huge number, and it's supposed to be a probability. Yeah.
I looked at them, I was like,
So,
I'm right.
like almost every time you have a percentage given, you're going to make it into the decimal because
Yeah.
math needs the number to work
I
with.
stick all of them to and C, because the only person.
Totally. Well, the thing with C is, at least one is the opposite of none. So when you redo this, whatever answer you get here, C is 1 minus that because they're opposites of each other. Yeah.
Okay.
Okay.
And then for these as well.
Oh, okay, so you made this mistake. All right, look at the thing, how many total people were there?
Yeah.
Total?
Yep.
That's right, because I'm like, I know how to do everything, but I don't know what I did was right, so I did everything right or everything wrong.
23? Did we leave something out? Let me see. I think there was one more category. Yeah, there's another category in here.
You can rip it.
All right, so 4 others, okay. So 7, 18, 23, 27, okay? All right.
Oh yeah, 4 others.
It's really strict.
Out of those 27, how many, for example, have T-Mobile?
5 out of 27.
So that means the probability of T-Mobile would be 5 out of 27. Yeah, the way you were thinking about it was you picked 2 people out of just the T-Mobile. But I didn't say anything about throwing everybody else out. I could still get any of the 27 people. Out of those, how many chances do I have to get a T-Mobile person? 5. So probabilities always have the total number it could be on the bottom.
Yeah. So it would be.
So was it T and then S? Yeah, so it would be 5 out of 27. And then times, what was it, sprint? 3. Isn't there 3 sprint people?
Oh, yeah. Wait, but then what if, oh, cause.
Because you were still thinking about 2 people.
Okay.
Yeah, this is the first person, and then this is the second person. That's where the 2 people show up. Yeah. Does that make more sense?
Yeah, and then without replacement.
Without replacement would just mean this goes to 26, because then when you pick this person, you're throwing them away.
I think I'm just.
And then if it was the same thing without replacement,
Then the tops would also go down, because if you pick a Verizon person and then throw them away, there's 1 less person and 1 less Verizon person, yeah. Cool. You're welcome.
and then I could still turn in my test questions for test 1 or no? Like,
Yeah, of course. You can turn in
Just-
quiz 1 corrections, you can turn in chapter 1 homework. Okay.
Do we have class tomorrow?
Well, tomorrow's final.
Confused here, yeah.
Oh, I still,
Yeah.
okay, because here's how I think, of it, right?
No, hell no. Yeah, summer session is over tomorrow.
Area of, right?
Yeah.
So if your total area is on.
So on the homework sheet, it's got the date
2 things,
for the
you know,
final.
Your total area is
Yeah.
0.05, and you got 2 things that make 0.05.
Yeah.
You got it. Yeah, that's why I gave the practice final,
I'll do this.
right?
Yeah.
Yeah.
Okay.
Wait, do you have
Don't worry.
for it?
I do, I just haven't given it out yet.
But I just have a problem with
If you want to, yeah.
wording stuff.
Yeah, no, it's because it's very
Mhm.
dependent on, like, what is, what's the word?
Bum, bum.
What, how you word it can change what you're saying,
Yeah.
even if you're trying to say something.
Yeah.
So you gotta make sure you use a couple things,
Yeah.
so that's like I was under the impression that, you know,
I overheard a discussion, and this is where I would expect a student to say, Mr. Waller, you're not teaching English, man. What the shit's wrong with if we turn this thing around? All right, so if I said, we are 95% confident that the true mean falls within this interval. It's like we set up an interval, and then the true mean is gonna fall. It's gonna fall into it or not. It's not what happens. The true mean exists. It just exists. And then we construct an interval. So we're such and so confident that the interval we constructed actually ends up holding that true mean. So if we construct an interval, hey, it might contain the true mean, and we're such and so confident that it does. Because somebody else could come along and make an interval and it doesn't. So if I make a 95% confidence interval, and a lot of other people do too, 95% of our intervals will hold the real mean. So how confident are we that our interval holds the real mean? 95%. So 95% confident that the interval blah to blah contains the true mean. And again, I know I'll never be able to say that to the point where everybody's like, oh, it's not just semantics, but it really isn't. It's actually, okay. What question do you know is going to be on every test, including the final?
Z-score.
What does the z-score tell you, or more specifically, what does the z-score of 3.8 mean, or whatever, right? And that is the number of standard deviations from the mean to that data point. You with me? So if I said, what's a z of negative 0.3, you'd say that means the data point is 0.3 standard deviations away from, or more specifically, below the mean. So z-score is a number of standard deviations from the mean to the data point. Standard deviation is the average distance every data point is away from the mean. Does that? So that's why it makes sense to use a standard deviation as a unit of distance. If that's the average distance all the data points get, then a z of 2 is where things start to get unusual, because that's twice as far as the average distance. That kind of makes sense to us that that's what we could call unusual, as that's where it starts. Does that make?
Standard deviation is more numerical, and z-score is...
No, they're both numbers. Yeah, so standard deviation is the average distance from the mean to the data points. So that's a number. Z-score is the number of standard deviations from the mean to a data point. So they're both numerical.
Oh.
Yeah. So guys, I forgot on the key, man, I totally forgot about this. Number 5 I was gonna do together with you guys. So I'll get this recorded. Number 5 is the one about the pizza and all that kind of business. All right, so let's see, I need both of these things. All right, so number 5 is this one. Well, you know, there you go. Oh boy. All right. Here's number 5. First thing I asked for is the 99% confidence interval for the true mean weight. So the very first thing you should do is throw all this data. Throw it away. No, put it into the calculator. All right, so 3, 7. Crappity doo-dah. 13, 4, 11, 4.5, 1.5, 11. And then 213, 201, 178, 176, 195, 180, 212, 216, 194. Yeah. This was me, by the way. I was this. Yeah, that was a rough time. All right. Now, the very first thing I asked for is the 99% confidence interval for the true mean weight. So I know I'm going to use X bar plus or minus. Now, I don't tell you any sample mean or standard deviation, so of course you have to use the calculator for that. So I'm going to have to use T, because I'm going to have a standard deviation for my sample, right? So how do I calculate the mean and the standard deviation? What do I do?
You can do numbers.
Yeah, it goes stat, calc, 1var stats. Which list am I wanting to look at? List 2, that's where the weights are, right? So I'm going to change this to list 2. There we go. So I know that the mean is 196.11. I got to look up my t-score. Standard deviation is 15.632 divided by the square root of 9. Can somebody help me? What do I need to know to figure out the t-score?
You need to know the degrees of freedom.
Degrees of freedom, what's that?
8.
8, because the sample size is 9. And what's alpha? 99% confidence? 0.01. All right, so look at your t-score chart.
It's a two-tailed actually. So
Confidence intervals are always two tails.
it's 3.355.
So two tail, 0.01, stop at 8, 3.355. And now I just got to throw all this business in the calculator, right? Are you guys, everybody with me so far? So obviously, in any given situation in the real world, I'm going to have multiple sets of data. I can talk to people and have them answer a bunch of questions. This is just an example of, okay, in part A, I only care about the weights. I'm only going to look at list 2. So now I can calculate the error. What was it, 3.355? Is that what it was? Yeah. Times 15.632 divided by square root of 9. Put this down here. So I get 196.11, give or take 17.482. And then what I do is I store that, so then I can do 196.11 minus that. No, Jeff. 196.11 minus x, 196.11 plus x. Or you can do whatever the hell you want to. So I'll get 178.63 up to 213.59. And then I can write a conclusion. Okay, so everybody with me so far? So first one, it's a sample. That's where I got the standard deviation. So I know it's a sample standard deviation, so I have to use a t-score. Now I want to get the line of best fits. How do I do that?
You calculate linear regression x plus b.
So where do I go?
Stat.
Stat, calc, this guy. Make sure this is list 1 and list 2. There we go. So then I know my line of best fit is negative 2.87 plus 218.58. And I know my R is negative 0.907. Now, I think on the key, I actually told you, because I forgot, or did I? Let's see. No, on the key I just said in class. Good job, Jeff. So, I can't remember, I think for this size sample, R's got to be, let me think, less than negative 0.7 something. So I would tell you that number, right? On the final, I'm going to say R needs to be less than or greater than something to show correlation. So did we find evidence for correlation?
Yes.
Totally. So what does this R tell us about the line of best fit? We trust it to make predictions. And then predict the weight for someone who lives half a mile. So now X will be 0.5, and I just throw that in the formula, right? My X's are weights, my Y's are, my X's are distances, my Y's are weights. So it would be negative 2.87 times a half plus 218.58. So I would predict they would weigh 217.145 pounds. And I feel pretty good about that approximation. And then, how do I graph this? Well, if you have your own calculator, in fact, at this point, most of the ones I let you guys borrow, it should already be set up for it. So whenever you put new data in, you hit zoom 9, and it finds the data points. I still haven't put my line of best fit in. So I'm going to put negative 2.87x plus 218. I think that's 5.8. And now that'll show up, and that looks like it's in the right place. And that's what you would come up and show me during the final. Woo! By the way, the final I'm going to give you is probably just going to be one question longer than the normal final I give during the regular semester. So the students would have 2 hours to do the final. So you guys are going to get just a bit more than 2 hours. Maybe 2 hours and 15 minutes, I think. I did that a little quickly. Is that all right? You guys, of course, it's on the video now. Yeah, that explains. I was looking at the key. I was like, wow, that's a really short key. And I forgot. Oh yeah, number 5. I didn't do it all. Yay.